Hey guys, sorry about that. Basically, it was because of recording. There was some issue with recording, it seems. I think it's now sorted. We can continue. Okay. So I was just recapping on what we have discussed on Friday evening, Friday evening. Okay. So we just started with functions and uh, we have tried to understand the syntax and other things, right? The basics of functions, basically how we define a function and what are the arguments or parameters and how we call a function are few things which we have discussed. Okay, so we'll move on and continue with the other examples. Okay, so let's say I have to implement what are the code we have written so far as functions. There are few functions. Okay, we'll start with uh, our EMI calculator. Okay, so now going back to the code, basically EMI calculator would take three parameters: principal, tenure, and rate of interest. I'm gonna take the basic version of EMI calculator. I'm not gonna get into this CIBIL score and other things. Okay, but I'm gonna take the basic version, which would take three inputs: principal, tenure, and rate of interest, and then we'll calculate how much we'll have to pay every month for us. Okay. So for example, I'm creating a function def get EMI, which would take principal, tenure, and then rate of interest as a parameter or arguments. Okay. And then it would return EMI value. Okay. And here we'll write the logic, how this EMI would be calculated and other things, right? So first things first, we'll be calculating simple interest, which is equals to P into T into R divided by 100. And then we'll be calculating total. Total is equals to simple interest plus principal. And then, you know, we have EMI is equals to total divided by tenure into 12, or maybe you can divide it to. Okay. So you can just put months is equals to tenure into 12. Okay. And then finally, EMI is equals to, you know, total divided by months. Okay. And I'm returning the same thing. Let me run this. So function has been defined. And now let's call this function, guys, get EMI of. Now you can pass principal, tenure, rate of interest, whatever you want. Maybe I'm gonna pass 2000, 20,000, 2 lakh, 20 lakh. Okay. And then tenure, maybe I'll give 20 years. And then rate of interest, maybe I'll give 7.56. Now this is returning 20.933. Maybe I'll round it to 2 decimal points. Okay. So 20,933. And let me save it to a variable, guys, so that I can use it at a later point in time. Okay. And let me print the same. Print EMI. Okay, 2933.33. So here I'm passing these values in a hard-coded fashion. Maybe if you want to read it from the user input, you can do that too. Okay, maybe principal is equals to, this is an integer value, and I'm taking input from the user using this input function. Maybe enter principal amount. Yeah, and then tenure. Tenure is again an integer value, int of input of enter tenure in years. Okay. And then, finally, you can have a rate of interest ROI is equals to, a rate of interest is a float value, float into input. of enter rate of interest. Okay. And maybe if you want to add if conditions, checking if the tenure is less than 25, you can do all those things here. My bad. Let me stop this. Instead of hard-coded values, I'll have to pass the variable names. So first is principal, and the second is tenure, and the third one is rate of interest. And the position, I mean, the position of these variables is very important, guys. Let me run this. I'm going to give the same values, 2000, 20,000, 2 lakh, 20 lakh. Enter tenure in years, maybe I'll give 20. And then rate of interest, maybe I'll give 7.65. There you go. This is the interest value, EMI, which you are going to pay. Let me take a pause. Are we good so far? Yes, no, maybe.
Yeah, we are good.
Others? Guys, I understand this is your Sunday evening, but I need some energy in the session.
Yes, we are good, Suresh.
Yeah.
Yeah, we are good.
So how did you enjoy your Saturday night? Which is, sorry, my Saturday night, your Saturday morning.
Of course, cricket.
Yeah.
India
Any
won.
any
India
cricket
won.
lovers here?
Of course.
Of
Yes,
course.
hats off to Surya Kumar Yadav.
Yeah, that one catch defined the World Cup for us.
Yeah, decided that.
Yeah.
But three legends were gone.
I mean, I got more excited by the way we won this cup rather than winning this alone, because at one point I thought we are gone. Not just at one point. This is like a climax. You know, every over is a climax. When we are batting, we lost 3 quick wickets, and they played really well. Akshar Patel and Virat Kohli, and then in the slog overs we didn't get the score we want to. So I felt we are 10 to 20 runs short. I mean, at least the position we are in at 15th over. But the way we came back again with the bowling, 2 quick wickets, and then again they played well. It was like a roller coaster ride. It was never flat. So this is how the World Cup should really be. I mean, at one point I was thinking ki at least even though India lost this game, I'll be happy because it's better than 2023 World Cup final where, once our batting is done, it was decided we lost the match. Yeah. So you partied after the cup? How were the celebrations in US?
Weather is so hot and we cannot do anything.
Okay, so when weather is hot, you should have sit at home and do something else. I hope you understood what I mean.
Yeah.
Yeah, there are a lot of, cool drinks available. Yeah. So in Hyderabad, party peaked at night, at around 11:30, 12 match was over, and then
The whole India
we,
picked.
yeah, at least I'm not sure about whole India, but I went out to really get that feeling because I did it in 2011. Back then I was a kid, I was studying my BTech. But now, I just went out and, experiencing the same thing after so many years was really, really special. Yeah. So show the same Josh, guys, in Python also. Okay, same energy, right? Let's move on to the next example. We'll try to write a function to check if a given number is an Armstrong or not. Okay. So now you tell me the function definition, how the function definition should look like. Def
Armstrong, get Armstrong.
Get Armstrong or is Armstrong, I would put.
Is Armstrong will be fine.
Yeah, because we are asking a question whether it is an Armstrong number or not. And then argument 1 to 5 arguments. How many arguments should I be passing? One should do, which is our number. Okay.
Yes. Yeah, but it can be multiple digit, right? So
Yes. So return, what should I be returning?
Just a minute.
True or false?
Yes. So I will be returning either true or false based on whether, this is whether we found it to be an Armstrong number or not. Okay. So you can actually reuse the old code. So this is your Armstrong number. Oh, this is not the one. Go in workshop, you'll get it. Okay. So this is the code for Armstrong number. Now what I'm going to do is I'm going to use the same code to create my logic. Now if I have num and I'm going to copy it from here till here. Okay. Now sum is equals to 0 and then temp is equals to num. And then the while loop. Proper indentation is very important, guys. Okay. So once the while loop is done, now my if condition. So here it's okay. We just used a print statement because it's not a function, right? But now what I'm going to do is instead of this, I'm going to use return. When num is equals to sum, I'm returning true. Okay, meaning it's an Armstrong number. Else I'm returning false Boolean values. Okay, so this should do the trick. Now let me take the input from the user itself. Num is equals to, and again the parameter name and this variable name need not be same. Okay, num is equals to int of input of, since an integer value we need enter a number. Okay, and then I'm gonna call the function is Armstrong. Maybe is arm is equals to I'm gonna call this function is Armstrong, and let me pass this function. Let me pass this as a parameter num. Okay, and it will print either true or false. If you want, you can add if conditions here as well. If it is true, then it's an Armstrong number. If it is false, it's not an Armstrong number. Okay, but I'm just printing true or false. Let me define this first function. And now I'm running this. Maybe I'm gonna give 153. There you go. It's a true value. And then maybe I'll give something else 181. Sorry. 181 false. Okay, so this is another way of implementing a function, guys. I mean, whenever you are creating a function to do a particular activity, okay, or maybe to check, or when you anticipate a binary output, 0 or 1, true or false, yes or no. Okay, so this is how we create those functions.
I have
Are we
a
good?
doubt, Piyush. I have a
Yeah,
doubt.
go ahead, Bhargav.
Yeah, in the return statement, as you said earlier, instead of writing if this is true, print true, can we write directly in the return, this is Armstrong number, like kind of that?
As a string,
Yeah, in the return
answer
statement. In the return
answer is
statement.
yes. Answer is
Okay.
yes, you can do. So basically you can return Armstrong. Okay, or you can also return not an Armstrong,
Okay.
but that's not professional.
Okay. Okay. Got
Okay,
it.
so
Yeah.
this is for our understanding. Yes, we can still do it. Maybe I'm giving 153 Armstrong. You see, it's a string value. but generally we do this Boolean check because at a later point in time, let's say you want to use this output for checking other conditions. This is quite handy. Okay. And
Okay.
also you don't even need to write if else and all these things, guys. Okay. You can just write a return num is equals to sum. If it is true, it will return true. If it is false, it will return false. Okay, I have written 4 lines of code into 1 line of code. These 4 lines of code earlier into 1 line of code. Okay, now let me run this. Let me give 153. If this condition is satisfied, it will return true. Okay, and if this condition is not satisfied, it will return false. Let me take a pause. Are we good?
Yes.
Yes. Yeah.
Okay, and a function need not return something every single time, guys. Okay, so for example, I'm just creating a function which doesn't return anything. Say hello. Okay, and probably I'm just printing over here something over here. Okay, hello all. Done. This can also be a function, right? And then probably I'll call this function. Say hello. It will just print hello all. Okay, since it is not returning anything, you need not create a variable. You need not create a variable to store the output. But if you are doing that, it won't throw an error, but it will store nothing in this hello. This hello will be a none type. Okay, when you try to print hello, you will not see anything in hello. None. You see? And maybe if you want to check the type, it will give you none type. Okay, when a function is not returning anything, you don't need to create a variable to store the output. Let me take a pause. Are we good?
So in other languages, we used to have, suppose I take in case of Visual Basic.
Mhm.
So there, if it is a function, if we want to return some value, we define as a function. If it is, you don't need to return anything and just a sequence of steps to be used even whenever you call it. We use it as a subroutine. Is it something,
Okay.
both are clubbed here, right? It's the same thing. If
Yes,
you want to
it's
call it, otherwise leave it.
yes. Okay, so there are a few examples, Satya, for the same. Okay, so for example, maybe you want to close a database connection, or maybe you want to save a file. They won't return anything, right?
Yeah.
Okay, so they're still reusable components because you do that multiple times at multiple places.
Yeah.
Okay, so you're just trying to print something. You don't really need to use this value going forward. Okay. So now we will take Fibonacci series for this example. Okay. So def fib, I'm calling this function as fib, and then it will take n terms and it will have to print n terms. Okay. So for printing n terms, we don't really need a return statement. Okay. Again, I'm going to use the same logic from our previous one. I'm going to take this one. Okay, we also need to understand what is needed and what is not needed, guys. Okay, so maybe I'm gonna take first two terms, which is n1 is equals to 0 and n2 is equals to 0. Okay, and then this is all needed. I'm gonna take the whole bunch. Okay, so n1 is equals to 1, n2 is equals to, so n1 is equals to 0, n2 is equals to 1, count is equals to 2. Check if the number of terms is valid. And then if n terms is less than 0, then I'm printing it. Elif Fibonacci, I'm printing n1, else printing Fibonacci sequence, printing n1, printing n2, and then while. Okay, now let me run this. Now maybe I'll give 5. It should print 5 values. It didn't. How many terms you want? 5. Oh, I didn't call that function. My bad. Okay. So fib of and terms. Then maybe I'll give 5. You see, Fibonacci sequence 0, 1, 1, 2, 3. Are we good? Guys, are we good?
Yes.
Yes. So you can see a difference. While I'm explaining Fibonacci earlier, I was using for loop, and I have given you as an assignment to implement the same logic using while loop. Okay, so you'll not see any differences. The only difference you see is, the condition over here when the count is less than or equals to n terms. Count is nothing but my iterative variable, which I initialized with value 2. Okay, and then I'm incrementing that count value every time I have iterated. Okay, so when it is less than n terms, I'm just coming out of the loop. Okay, are we good?
Yes, yeah.
Cool.
Yeah.
So one last concept in functions, guys, which is recursion. Okay, so again, this is one concept which I'm yet to use in my real-time environment. Okay, function calling itself, right? But still we'll discuss because recursion is there in functions. Now, any idea what exactly a recursion is?
Repeating.
Okay. Here you go, recursion. So any other definitions of recursion? Yes, no, maybe?
No.
No problem.
Calling the same function from within the function.
Calling the same function within the function. Yes. Okay. So basically the mechanism of calling a function itself is called as recursion, guys. Okay. I repeat my statement. A function calling itself is a recursion. Okay. So we'll take a basic example and then we'll see one application of this recursion. Just give me a second. Now, just a moment. I'm connecting my Wacom. Okay. So when you're calling the function inside a function is what we call as recursion, guys. So this is how it would look like typically. Define function name. whatever the parameters that are needed. You write some function, and then if you're calling that function again inside this function, this is what we call as recursion. Okay. And you might ask me, boss, when you're doing this, it will go into a loop, right? Infinite loop. Answer is yes, it will go into an infinite loop, and you'll have to provide a breaking condition as well. Okay. So let's try to understand how it actually works. Okay. So here I'm creating a basic function. Okay. And just to explain you how recursion works. Okay. So def example recursion exrec. Okay. And then it is taking an input k. If k is greater than 0, then what I'm doing is result is equals to k plus example recursion of k minus 1. Else result is equals to 0. This is the breaking condition. This is the breaking code, and this is the condition to break it. Else I'm returning the result. Okay. Now let me show you how this works. Going back to my whiteboard. Okay. Now what I'm going to do is I'll just write the function again here. Def example recursion of k, right? If k is greater than 0, then k is equals to k plus example recursion of k. Okay. Else k is equals to 0. Yeah. Is this what we have? Result is equals to okay. And then finally I'm returning result. Okay. This result is equals to k plus example recursion, else result is equals to 0, and return R, which is result. So this is the code. Now let me show you how this works. Maybe I'm calling example recursion of, we'll start with a simple number 3. Okay. Now first things first, it will start here. Example recursion of 3. This is my function call. Okay. Now this is the k value. This function would be called k value is greater than 0. Now if R is equals to, result is equals to 3 plus example recursion of, my bad, it's not example recursion of k, it is example recursion of k minus 1. Okay. Now example recursion of 3 minus 1, which will be 2. Okay. Now this will be called in loop. Example recursion of 2. Now if the k value is 2, R is equals to 2 plus example recursion of 1. Okay. Now again we are calling this function, and k value is greater than 0. Result is equals to 1 plus example recursion of 1 minus 1, 0. Now this is calling this function again with k value 0. With k value 0, this condition is gone, and it will go to this condition. R is equals to k value is 0. There is no this thing. Now this is not needed. This is executed. Okay, which means you are no more calling example recursion, guys. Now it will go back. Now the value is 0 for this. 0 plus 1, the output will be 1. Okay, and this output will be 1. The total output for this R will be 2 plus 1, 3. Okay, and 2 plus 3, 5. Sorry, 2 plus 1, 3. Now the output for this is going to be 3. 3 plus 3, 6. Okay, and your final output would be 6. Your final output would be 6. Let me take a pause. Are we good so far?
So why do we need to do like this? Where do we use it in real time?
I'll get there. Again, real time, I don't have an example, Satya. I have never used it.
Okay.
Honestly. Okay. But like I said, just because we have this concept, I'm just explaining you, because generally whenever we want to loop something or check for a particular condition, at least I go for infinite loops. Okay, so I don't really define a function and then create this, but theoretically, I'm gonna give you, few examples where you can actually go with recursion, but real time I have never done this.
Okay.
Okay. Now, but are we good with the concept, guys? Everyone?
Yes, Suresh.
Yeah, Suresh, you are just substituting the value every time. That's it, right?
I'm not actually substituting. See, for example, if you see, this have formed a chain or a tree. Okay.
Yeah, from the bottom of the chain to top of the chain, you are
Yes.
replacing the value.
It's not replacing. I mean, this is something which is returned. This
Okay.
0 has been returned by example recursion of 0, right? Example recursion of 1 returned 1. Example recursion of 2 returned 3. Okay. So basically you're calling function inside a function inside a function, and you are actually summing up all the returned values.
Yeah, got it.
Okay.
Okay, got it. Yeah.
Yeah. Now basically these type of recursions are used whenever you want to perform the same action multiple times. So for example, you have an arithmetic progression, sorry, not arithmetic progression, Fibonacci series, where you have first two values zeros and one. You can avoid this though. And from second onwards, I mean the third value onwards, you'll have the same logic. So 0 plus 1, 1, and then 1 plus 1, 2, and then 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, 13 plus 8, 21, so on and so forth. Okay, so whenever you have a logic which you are repeatedly using, right, that is when generally we go for recursion. Okay, theoretically, but like I was mentioning earlier, I'm yet to come across one such use case. I don't want to cook up something. Okay, but this is one concept which I have never used. Okay, so I'll keep telling you this thing, guys. I mean, whenever I'm teaching you something which I have never used, which means that topic has less significance or you need not focus a lot on that. I'm still teaching you just because we have that concept in this thing. And like I said, our batch is a mix of experience ranges, right? We have people with a lot of experience. We have people who are freshers. So these concepts are really important for freshers. Okay, because uh, they might get questions on this in their interviews, but definitely for an experienced folks, I don't think so you would get any questions on this. At least I never asked. Okay, now moving on, I'm going to implement the same Fibonacci here, guys. Right, so def Fibonacci of n. Okay, if n is less than or equals to 1, this is my breaking condition. In that case, I'm returning 1. Else, I'm returning Fibonacci of n minus 1 plus Fibonacci of n minus 2. This is the logic which we are repeating, right? Fibonacci of n minus 1 and Fibonacci of n minus 2. Okay, so the current value of n is nothing but the sum of its two previous values. Now let me run this. When I do Fibonacci of 5, it will give me 8. Maybe like if I do Fibonacci of 1, it will give me 1. Fibonacci of 2 will give me 2. Fibonacci of 3 will give me 3. Okay, you might ask me, boss, then what happened to 0 and 1? 0 and 1, you cannot generalize it, right? Because if you go back, sorry, if you go back to the definition of Fibonacci, these two are the only ones which are not following any pattern. They are some static values. So when you implement Fibonacci function in recursion, your first term will start from here. Okay, Fibonacci of 1 will be 1, Fibonacci of 2 will be 2, Fibonacci of 3 will be 3, Fibonacci of 4 will be 5, Fibonacci of 5 will be 8, so on and so forth. Okay, now if you want to print all the values, okay, so you can leverage the same function and then loop it. Now this is how I'm going to do it. I'm taking number of terms from the user If it is less than 1, I'll ask user to enter a number greater than 0. Else I'm printing 0. And then, I'm using for loop and calling this for loop by passing this, value to get the number of terms. So in the first iteration, we'll get the first term, second iteration, we'll get the second term, third iteration, we'll get the third term, so on and so forth. When I run this, maybe number of terms I'll give 8. You'll get 8 terms, 0, 1, 1, 2, 3, 5, 8, 13, so on and so forth. Let me take a pause. Are we good? Yes, no, maybe.
Good, Suresh. Thank you.
Others? Okay.
Yes, I'm good. Yeah.
And assignment for you. So whatever I have written over here, right, I want you to go and, deep dive in this way. Okay. So take the Fibonacci function definition and then start with a simple number. Start with 1, start with 2, and then see what's happening. Okay. And then you can do that up till maybe 5. That should do. Are we good?
Yeah.
Cool. So I understand this is your Sunday evening, guys. I'm not gonna push you further. I'll let you go and prepare for your Monday battle. Okay. I just want to complete functions today, right? And when we meet tomorrow, I'm gonna start arrays. Arrays would take around half an hour, guys, because we'll not deep dive into arrays. We don't use that much. And we'll start with collections, lists. Are we good?
Yeah.
Yes.
Awesome. But if you want to utilize the rest of the time, I would recommend you to complete the assignments, that Armstrong number, and then this Fibonacci tracking, how it works.
Can you repeat the assignment, please?
So what I want you to do is take this code and track the code, how it works, backtrack the code, how it works for inputs, where n is equals to 1, n is equals to 2, n is equals to 3, like the way I did here. This one, you see? Make sense, Lakshmi?
Yes, yes.
Cool. Okay. Thank you all. Have a great weekend and meet you tomorrow. Thank you.
Thank you.
Thank you.
Thank you.
Yes, Suresh.
Thank you.
Got you. Thanks.